Hello, dear students. Today we have the last proposition of Book 1. So from now on, I'm going to start putting the Roman numeral there for the book and then the regular number for the proposition. Today we have Prop 148, and we're going to use the famous Prop 147 to get this prop. See, this is an easy prop if you have Proposition 147, okay? Proposition 48. If in a triangle, the square on one of the sides equals the squares, the sum of the squares on the remaining two sides, that triangle is a right angle triangle, okay? Here we have our given, a triangle, and it's given that the square on one of the sides is equal to the squares on the remaining sides. Thus, it is required to show that that triangle is a right angle triangle such that the squares, the lines with the squares on the remaining sides are the ones containing the right angle, okay? Triangle, this square equals these two squares, this is a right angle. In any triangle, if the square on one of the sides is equal to the squares on the remaining sides, those lines, those remaining sides, will contain a right angle, okay? Bag of knowledge, we're going to draw an angle equal to a given angle, okay? We're going to rely on Prop 147, and then of course, as always, two things equal to the same thing or equal to each other. Great. So let's get started. We're going to start by drawing another triangle. From this point, we're going to draw a line that contains an angle equal to a right angle. So let's do that. At this point, and with this line, we're going to draw a line such that it makes a right angle here. Okay? And then from the greater, we didn't do that here, this is for a bag of knowledge as well. From the greater, cut off a line equal to the lesser, hold it fixed, etc. We don't have to redo the prop. But from the greater line, cut off a line equal to the lesser. So let's do that. Make it look somewhat equal. So it appeals to the imagination as well. Okay? And then we're going to connect these 2 points. Okay? So here we have a right angle triangle. So we know we proved in Prop 147 that in all right angle triangles, the square on the hypotenuse is equal to the sum of the squares on the sides of the right angle. Okay? So the square on this hypotenuse will be equal to the square on the sides, okay? So here we have two triangles. Let's separate them over here. I'm going to do this once just so you can see things. Here's our red triangle, here's our green triangle, okay? Here's the square on the hypotenuse, here's the square on the hypotenuse. Here's the square on the little side, the square on the little side. Look at this, this is where it might get a little confusing. Here's the square on this and the square on this, okay? The best way I think to do this prop is don't even try to imagine the squares. Don't even try to imagine the squares. Just now you know that because this is a right angle triangle, the square on this is equal to the square on this and the square on this. Okay? That's from Prop 147. But it was given now that in this triangle, the square on this is equal to the square on this and the square on this. Great. So let's work to that. We know we need some middle terms to get those things linked up. Let's start by this. We know we made this equal to this. So we know the square on this is equal to the square on this, right? Two lines are equal, the square on those two lines are equal, obviously, because you can just show through coincidence. I'm actually surprised that Euclid doesn't take the time to do that. Maybe it's implicit somewhere. I know it's implicit somewhere. Okay, so the square on this is equal to the square on this. Let's add the square on this to both sides of that equation. So now we know that the square on this and the square on this is equal to the square on this and the square on this. Okay, no problem? Okay, but the square on this and the square on this were given to be equal to the square on this. Square on this. Okay, so it has to be, because two things equal the same thing or equal to each other. The square on this is therefore equal to the square on this and the square on this. But it was given that the square on this, because this is a right angle triangle, not given, but it's necessarily the case. The square on this is equal to the square on this and the square on this. Okay? Since the square on this is equal to the square on this and the square on this, and the square on this is equal to the square on this and the square on this, the square on this is equal to the square on this. Two things equal to the same thing are equal to each other. This square and this square are both equal to the square on this and the square on this. So they're necessarily equal to each other. Okay? So, if the squares are equal, then the lines are equal. So if the square on this is equal to the square on this, it's clearly one of the lines are equal. I don't know if that's true. Let me think for a moment. How do we want to show that this is a right angle? I don't know if that's necessarily true, because it seems like, yeah, if they're squares, they would have to coincide. Yeah, you couldn't have two squares being equal at one square. Okay, so the line is equal to the line. Okay, so now we have this side is equal to this side is equal to this side, and this is equal to this because it's the same line. So you have two triangles, side, side, side. Oh, I didn't tell you that. That's in a bag of knowledge today. Side, side, side. If two triangles have two sides equal to two sides, and the remaining side equal to the remaining side, the triangle will be equal to the triangle, and the remaining angles will be equal to the remaining angles, namely those which subtend the equal sides. Well, this was proven to be equal to this, and this subtends this, and this subtends this, and this was drawn to be a right angle, so therefore this must be a right angle because it's perfectly equal to this. So we see then that this is necessarily a right angle triangle, and with this square equaling this square and this square, okay? So therefore we have shown that in any triangle such that the square on the one of the sides is equal to the square on the remaining sides, those remaining sides will necessarily contain a right angle. Quod erat demonstrandum. Thank you. Bye.